it supports Q or not Q? Because it doesn't support P. Okay. Now, what about all the substates of these things here? So, we may as well, for example, look at this guy here. Yes, if it supports P, it supports Q, because it doesn't support P. Right? P is true here, false there. So it doesn't. Conditional is true of it. It is true of every substate of this large triangular thing. It's true of this because it doesn't support P. It's true of this because it doesn't support P, and of this. Now, if you look smaller, if you look at smaller states, you actually find one that supports P, but that is okay because it also supports Q or not Q. And down here you pretty much get the same. Oh wait, what did I just do? This would not wait. If P, then Q or not Q. Wait. Oh yes, no, it's okay, right, of course. This here, yes, it supports P and Q or not Q. Yeah. So only this guy here, the layer across, that is out, because it supports P but not Q or not Q. These are the two possibilities that we get for this sentence. These are the two maximal states that support this sentence. And each of them is a denotation of a conditional. We already had this. This is if P then Q. This is if P then not Q. And the definition says precisely that these two things, that's in the picture at the top of page 5, the right-hand side, B, that is the denotation of if P then question mark Q. One more thing. What about this? Okay, let's see. Do we have? This is the last thing I want to do. So we are slightly over time, but come on. Okay. So again, this is P or not P. Over here, if this is in the antecedent of the conditional, things look slightly different. But let's work through that again. 0, 1, 0, 0, and just see what we can get out of this. Now, it's clear actually each of these little ones supports the antecedent. Obviously, because the antecedent always has just one truth value in each of them. Okay. Each of them supports it. Now, if that's the case, then we have to get rid of the ones that don't support Q. It's these two here. Okay. Right. So now here, these are actually ones which make the sentence true. They support support P or not P, and also Q. Now, okay, well, but for example, this one is okay as well, because it doesn't support P or not P, right? P is true here and false there. Sentence doesn't support P or not P, because it has to support either P or it has to support not P. It doesn't support P or not P, therefore it supports this sentence.
But it doesn't support, well, why doesn't it support P or not?
Because for disjunctions, you have to support either of the conjunctive or the disjuncts.
It supports not P. Not P or not
So,
P, oh I see.
Yeah, P or not P, right. So it's the strong version of disjunction. Okay, now this here supports P or not P, but not Q. So that's actually out. Likewise, this up here supports P or not P, but not Q. So, yeah, these are out. Well, okay, but are we maximal? Not really, right? Let's see. Because we have larger sets which support the antecedent in virtue of not supporting either of the disjuncts. This one, for instance, fails to support P or not P. Because it's true in some and false in others. Therefore, the sentence is supported in this. Likewise here, any kind of mixture of this kind is okay. This as well. Okay. In fact, come to think of it, what about the set of all states? It doesn't support P or not P. Now let's see, we have to be careful here actually. Is it true of the set of all states? Is the following true? For all subsets of this, if they support the antecedent, they also support the consequent. It is true. Or isn't it? This is pretty tricky. It's not, right? Because actually where Q is false, we have substates here. This one, for instance. Oh wait, did I say before that all of these are okay? I was wrong then if I said that. We have to trace the video. This thing here, the small one, actually it supports P or not P, but not Q. Oh, so these two are actually out. So this is where I wanted to end up actually. So where I wanted, I know the solution, and you should too. If you saw my talk about unconditionals a year ago, this is the state, the maximal state that supports this thing. This is an unconditional of the kind, it's a sentence which you can think of as regardless of whether P or not P, Q. Something like, with free choice items in the antecedent, something like that. Regardless of whether, and if you have more alternatives in your question, you get the same result. Regardless of which answer is true, Q is the case. So having a question in the antecedent automatically gives you an unconditional. Now an unconditional is this kind of conditional that says precisely not that Q depends on whether P, but Q doesn't depend on whether P. So I thought when I did this, I actually did this last night, we're trying to fiddle with these things. I thought that was very helpful. I hope it was for you too. So, is there any moral we can draw from this? Well, I don't know. I should just leave it at that. So. Just to remind you here, so now these guys, obviously you see how the overlapping account falls out from this. And now this unconditional business, this is a nice feature that I like about this, but it's sort of irrelevant. Perhaps I should say there's one thing in the definition of the conditionals. So we have this sigma supports P, if P then Q, if and only if, blah blah blah. So then we have this for all tau that are subsets of sigma, and then blah, blah, blah. We were talking previously about these stack things where we were pushing something on top of this, getting a state which supports the antecedent, and then asking whether it also is, and actually I'm not talking about update here, but it was about this state derived from this supporting the antecedent and then the claim was it also supports the consequent. Perhaps you can see that if you actually define it this way, it comes down to something very similar. I mean, this is not about the state you obtain by updating with the antecedent, which is good because in case the antecedent is inquisitive, you may get more than one state by updating with it. But then you say pretty much the same thing, so that, whichever way you end up learning that the antecedent is true, the consequent is also true. I think of this as, well, since it has this intuitionistic flavor to it, you can see, I think, a connection between this stack business and this where it's defined. And it's not surprising that ultimately the result of updating with a conditional question should be this, a state which has, well, actually, conditional sentence, sorry, it should be this, yeah, in both of these cases. Right. Yeah, and if you carve up this according to the consequent, the interrogative consequent, then depending on what the answer is, you will end up with either of these two possibilities at the end of the day. So there's a deep sense in which the Isaacs and Walden's picture and the Grönenberg and Rudolphson picture are doing the same thing. And it's a matter of, well, other things. Other criteria may decide what one's better. Okay, anyway, that's it. Thanks. Yeah. Sorry. Oh, clap, no, clap for it, come on. Okay.
So I'm just trying to have a take on what these guys are doing, right? So I'm just wondering if one of the, you can see them as really, so you get inquisitive meanings for, I mean, it's another way of dealing with alternatives.
Yeah.
Right? So they give you a meaning for expressions with alternatives without ever overtly introducing alternatives.
Mm-hmm.
Is that kind of a way of seeing what they're doing?
Yeah, I would say so, yes. I mean, I don't know what you mean by not overtly introducing alternatives. The disjunction does it, basically.
It does it, right.
Mm-hmm.
And you end up with an inquisitive meaning, which means you keep the alternatives around all the way.
Right.
All the way.
And so
for some of these guys, though, eventually you might start with alternatives because some of the expressions bring them along, and you end up without having them.
For instance,
right.
Yeah. So, for instance, I remember that this P or Q, which was this, right? And then I had P or Q, which was this. I think I also actually double negation of this guy also gives you the flattened version. So there are various ways in which you can get lost, in which you can lose the alternatives. I mean, there's one thing that they like about it very much, namely Grönenberg, I think, is very fond of, namely that whether a sentence is inquisitive or not doesn't depend on its form. All these formulas, no, you can actually, maybe you could, but they don't define something like a sentence is inquisitive if and only if it has a question mark in front of it or anything like that. They don't do that. Sentence is a sentence, period. It's inquisitive if it has more than one alternative. That's a semantic.
They put it in the semantics. Yeah.
So that is one thing that I know Grönenberg is very fond of, and it's neat. Yeah.
So are there formulas that are inquisitive by their very form?
Well, that's an interesting. Well, this I don't know actually. Even disjunction isn't right because if you happen to end up with only one alternative, then not. So, although I mean, actually, it's hard to think of. I mean, if you had a first order picture where you could say something like either everything is identical to itself, or it's not the case that everything is identical to itself. One of them is the space of all possibilities, and the other one is empty, right?
Yeah.
And so even though this has a disjunctive form,
Right, exactly.
it's not inquisitive. So if you can do things, so that yeah, I don't know if there's any particular form of which you can be sure that it always is one or the other. Yeah. Well, thank you. Yeah, all right.